जितेंद्र जितेंद्र
जी सर।
आपका ये कौन सा ईयर है, ये जो चल रहा है, वो सेकेंड ईयर की फर्स्ट ईयर?
फर्स्ट ईयर है सर।
फर्स्ट ईयर। फर्स्ट ईयर। आपका बाकी सब पेपर प्रैक्टिकल के थोड़ा बाकी पेपर कंप्लीट मतलब क्लियर हो गया है?
नहीं सर, अभी तो कुछ भी नहीं हुआ।
एग्जाम स्टार्ट किया, कुछ भी नहीं हुआ?
अभी जनवरी में एडमिशन किया मैंने इसमें।
एग्जाम उड़ीसा में है क्या?
नहीं सर, राजस्थान।
राजस्थान में?
राजस्थान सर।
अच्छा, थोड़ा एक मेडिकल इशू है तो बात में डिस्कस करते रहेंगे। एक्चुअली कल तुम दो थे, आज एक ही है।
चिन्मय को मैसेज तो किया ज्वाइन करने के लिए।
क्या क्या बोल रहे?
चिन्मय को बोला तो ज्वाइन करने के लिए।
हाँ हेलो।
क्लास ज्वाइन करने के लिए चिन्मय को मैंने भी कॉल किया था, वो भी उठा नहीं रहा हूँ।
हाँ नहीं, मतलब क्या मैंने क्लास क्यों नहीं आते, मतलब प्रॉब्लम क्या है?
पता नहीं सर, मैं जब से क्लास ले रहा हूँ कोई आता ही नहीं है।
कल आपने जो पेपर आपको कुछ आया कि नहीं आया?
आया सर।
कल कल जब मैंने
उससे मैं थोड़ा बहुत फैमिलियर भी था, क्योंकि मैं अभी कंपनी में काम कर रहा हूँ ना।
स्टूडेंट्स क्लास ये वंडरफुल करना। नहीं नहीं, हाँ चिन्मय have joined.
Yes, sir. Yes.
Actually, I am on the bus. I'm going to attend
Okay, sir.
one urgent medical case has come. So I'm on the bus. So I will try to just speak something once all is there. Just 2 minutes, okay? No problem.
Okay, sir. Okay. S-
Only me.
Sir, should we postpone the class?
हेलो, हाँ बोलिए।
सर वो क्लास में पोस्टपोन कर दो कि आपको ଆଉ କୋଉ ଦିନ
କ୍ଲାସ୍ ପ୍ରୋବ୍ଲେମ୍ ଅଛି।
ନା ମାନେ ଆପଣଙ୍କ କଥାଟା କଟୁଛି ନା ସେଇ ପାଇଁ କହୁଥିଲି।
ତ ଆଗେ ଆଉ ଥରେ ତାକୁ ପରିଚୟ ପାଇବାଟା ମୁସ୍କିଲ ହବ ନା। ତାପରେ ଆମେ ମାନେ ଖାଲି ଇଏ ଥିଲା, ମାନେ ଅନଲାଇନ୍ ଥିବା ହେଲା କି ନାହିଁ? ଅନଲାଇନ୍ ଥିଲା
ସାର୍ ଆପଣଙ୍କ କଥା ଶୁଭୁନି, ମାନେ କଟୁଛି କଥା।
ହ୍ୟାଲୋ, ଶୁଣାଯାଉଛି?
ସାର୍ କଟୁଛି, କଥା କଟୁଛି।
ହ୍ୟାଲୋ, ଶୁଣାଯାଉଛି?
ହଁ ଶୁଣାଗଲା ଶୁଣାଗଲା।
ହଁ ସେଠି ଡିସ୍କସନ୍ କରିବା ଟିକେ ଆଉ କଣ। ମତେ କୁହ, ଏବେ ତ ଶୁଣିପାରୁଛ ମୁଁ ଯାହା କହୁଛି, ଏମିତି କହିଲେ?
ଶୁଭୁଛି ସାର୍, ଏଇ ଯୋଉ ବସ୍ ରେ ଯାଉଛନ୍ତି ସେ ବସ୍ ହର୍ନ ହେରିକା ଯୋଉ ବାଜୁଛି ସେଟା ଟିକେ ପ୍ରୋବ୍ଲେମ କରୁଛି।
थोड़ा साउंड आ रहा होगा ना? यस।
हाँ
बस का
साउंड आ रहा है।
ना, जा रहा है बस में तो साउंड आएगा। ठीक है, वो पूरा डिस्कस कर लेते हैं। ओके, डिस्कस कर लेंगे, नहीं तो मतलब क्या कि मतलब आज क्लास करेंगे, लेकिन जो भी डाउट्स रहेगा कमिंग क्लास में हम जगह एक्सप्लेन करेंगे।
ओके ओके।
मैं पहले का PDF खोल रहा हूँ। Can you able to see the screen?
Yes, sir.
Unit 6 is kinetics methods of analysis. Can you able to see the screen? Yes.
Yes, sir.
So, so you see here, you have types of kinetic methods. You can see here, as you know one thing, remember, the kinetic method means the rate of reaction. Any chemical reaction which takes place in you can, I think you know dx by dt means change in concentration with respect to time. That is called rate. And rate of a reaction is nothing but concentration with respect to time changes. For example, there are different types of reactions. Like kinetic reactions may be enzymatic, means it may undergo in terms of enzyme. Other reactions may be autoenzyme. For example, you are adding an enzyme, and the enzyme may not take part in the chemical reaction, but it can initiate the reaction and it can propagate the reaction. And remember always the catalytic reactions, catalyst means it will enhance the chemical reaction, but does not involve the process itself. So chemical kinetics is nothing but the study of the rate of the reaction, and rate of reaction is nothing but change in concentration by change in time, dx by dt. So whenever any type of analytical methods we are going to determine the rate of a reaction, then normally we are using the chemical kinetics. So our methods of determination is nothing but the methods of chemical kinetics. So you see now, for example, you can see there is non-enzymatic reactions and also enzymatic reactions. And then non-catalytic methods are there. Then remember, if it is many methods are there, but during kinetics, you have to see about that how the chemical reaction takes place. For example, I will say a first order chemical reaction. A arrow B. A is the reactant and B is the what? B is the product. So you see here that whenever a chemical reaction occurs, there will be disappearance of the reactants, there will be an appearance of the product. So remember always this, how much of the quantity of the reactants will disappear, the same quantity of product will appear always. Hence, it is called a rate of disappearance and also called rate of appearance. Always remember, rate of the disappearance is equal to the rate of appearance. You can see, you can see one reaction here in the graph there. You can see the graph. You can see the graph. Graph is concentration versus time. You can see the A is the reactant, and you can see its concentration is decreasing. P is the product. You can see its concentration is increasing. So you find a point of intersection where the A graph and P graph meet together. This is called equilibrium point. Means there the rate of formation is equal to rate of dissolutions. Means the substance which are reacted and change into product, the rate is same. Rf equal to Rb, or rate of forward reaction equal to rate of backward reaction. We can say it is a equilibrium state. But common sense, we remember that in a rate of chemical kinetics or in a kinetic process, always the product concentration increases gradually and the concentration of reactants decreases gradually. And there will be an equilibrium point also reached. You can say different graphical information you can see that P versus A, right? And also you can see that you know that the chemical kinetics are maybe zero order reaction, maybe first order reaction, maybe second order reaction. Depending on the rate of reaction, the order may be zero order, first order, second order, third order, like this. Okay, so remember these things. Then you can see that sometimes we are also using reaction chemical kinetics by fixing time. For example, for a particular reactant, you have fixed time. Time is fixed. Then you see the change in product or delta P is always a constant, and it increases with increase in the concentration of the reactant. Well, if the initial concentration is A0 and delta P is the change in the product concentration, then you can find a straight line graph passing through origin. That is called okay. The next is integration method. You can see here whenever you take the logarithm of the concentration of product with respect to T half, then you can also get a graph, tangent graph. Here, here you can see T. T is the time taken for the reaction matrix, and log P is the product concentration logarithm. Means if you take the logarithm of the product concentration, and if you take the distance of the time interval and draw a graph, you can see a graph like this. Log P is plotted against a function of T. See, remember all these things that we are discussing about a reaction which is fast order in nature. So with the fast order in nature, then you know that there is a kinetics formula K is equal to 2.303 by T log A0 by A concentration. Log A by A minus X means log A0 by concentration of A. A is the concentration after time T. A0 is the initial concentration and T is the time. So this is called the rate kinetics of a fast order reaction. So if you are plotting the graph between the product and the reactant, between the logarithmic of product and the time, then you get different graphs. The nature of the graph is also different, and you can see in the graph that the different nature of the graphs are there. You see then induction period measurements. For example, the two reactants, they combine and then the product P is formed, and the reaction is very slow, and you know very well the rate of the reaction can be calculated only if the reaction is very slow. So slow reaction is called rate determining step. Means rate of reaction can only be determined if it is a slow reaction. So you can see here A plus B whole product P. Then I can see here that then you can also derive the rate expression. First of all, A plus R equal to P dash then B plus R equal to P double dash. It's a mathematical calculation of calculating the rate of a reaction. You can see the last and then you have a logarithmic explanation to explain how the reaction takes place. You can see here log P minus P1 time, you get a straight line graph. So these are the kinetic methods which are very much useful in determining by in studying the analytical part of the compounds. But remember, these are all practical things. You have to take data. Data is plotted on the graph paper to make it, and the graph has been analyzed to explain that whether the reaction has happened or not, how much of the product has been formed, how much of reactions has been consumed. All these things you know from the data of the things. Then there is proportional equation methods, acceleration and inhibition, measurement of partial rate of orders. These are the things you should just read it. This is not so much to discuss. You can see here. There is the theoretical part. The rate law, just I have explained you. The rate law for fast order reaction. You see the rate law AT by A0 equal to e to the power minus KT or AT equal to A0 e to the power minus KT. This is the exponential equation of rate law of a fast order reaction. This is there in the plus two science. If you have read in plus two science, I think you have gone through the equation how to derive the rate kinetics of a fast order reaction. Then you can see half-life period. You know T half equal to 0.693 by K. K is the rate constant of fast order reaction. T half is equal to 0.693 by K. This equation is derived when the concentration of the reactant is half, and at that moment the time required is called T half. Means A is equal to A0 by 2. Means concentration at a particular time period is half of the initial concentration. Then that time required to disintegrate half of its value is called as the half-life period. You can see, then, then you can see the graph. The time versus the concentration of AT. When AT is taken versus time, a parabolic graph, a concave graph is formed. The graph you can see on the screen. Similarly, rate law of second reaction, A plus R K product. The second, then you can see the oxidative reactions is there. And similarly, you can see there are various types of rate of reactions and the equations are there. This is not a detailed study is not required in this case. It's not required in this case. The next is your yes. Then you can see instrumentation means how this instrument means symmetric diagram of the stopped flow technique. You can see there is a reagent, there is a drive mechanism, there is a sample. Then you can see A and B are there. They are first mixing together, then going to the drive engine, and then for the drive engine, they are mixing together. Then you are giving the light source, then you have photo detector, and you can get the type of graph. The graph is also mentioned there. This is called sheet. Then remember chemical kinetics reactions may be taken place in either in a closed system or in an open system. In a closed system, mixing operation is done manually and automatically and used for the study of slow reactions. But in an open system, they are commonly used for the study of fast reaction, kinetic, with the help of flow systems or batch systems. Then remember, from the detection system, you can also analyze the graphs like UV visible spectroscopy, then ultraviolet spectroscopy, fluorescence spectroscopy, NMR spectroscopy. These are the spectroscopy used during that method to analyze the compound, the mixture of the compound, or what are the impurities present in the compound. Also, you can measure. For this kinetics method, the method is called as the systematic diagram of stopped flow technique. Then applications. There are many applications of kinetic methods. Industrial effluents means you know that in industry normally many chemicals are prepared with the help of water or a particular solvent. We can call it effluents. So you can able to know the environmental chemistry, that is water and effluents used during preparation of industrial solutions. Then also it is used in clinical and pharmaceutical chemistry. Then also it is used in geochemistry, also in agriculture chemistry, food analysis. In this particular areas, the kinetic method of application of time is used to determine the composition of the compounds. Then you can see some questions are there. See, it is written A plus 3 B is equal to A plus 2 B is equal to P. What is the overall rate of reaction? Remember always, writing the equation doesn't imply the overall reaction you can calculate. But there must be a rate of reaction. For example, dx by dt is equal to k into a to the power a1 b to the power 1. So if it is in terms of the rate of reaction, then the addition of the exponents of the a and b will give you the order of reaction. For example, dx by dt is equal to k into a to the power 1 and b to the power 1, then 1 plus 1 is equal to 2, so it is called a second order reaction. Okay, in this way, order the reaction can be calculated. Only writing a plus 2b is equal to p means third order, which is wrong. We have to see that the rate of reaction must be expressed in terms of an expression dx by dt is equal to k into concentration of a to the power x and b to the power y. If you add x plus y and x plus y either are experimentally determined exponents. If you add x plus y, then it gives you the order of the reaction. Can you understand? Can you hearing all these things or not? Hello? Hello?
Yes, sir.
Are you
Yes, sir.
hearing? Okay, okay, then, okay.
Okay, sir.
Oh, yes, okay. The next is, next we go to the second chapter, the second one, unit 7, that is acid-base equilibrium. This is called acid-base equilibrium. Here you see that acid-base concept, there are three concepts actually. One is the Bronsted theory concept, then next one is Arrhenius concept, next one is Lewis concept. So I think you know Arrhenius concept means what? Arrhenius concept means anything which on revolution gives you H plus ion is called acid. Anything which revolution dissociates into gives you OH minus ion is a base. This is simply called Arrhenius equation. Arrhenius equation is simply explained in terms of the compound on dissolution, whether it produces H plus ion or H3 plus ion and OH minus ion. If it produces H plus ion, it is acid. If it produces OH minus ion, it is a base. Then Bronsted-Lowry concept means donation and acceptation of proton is the main criteria for explaining the acid or base. For example, I will say that HCl it can donate H plus ion, so H is an acid. But I can also say that OH minus ion, OH minus ion can gain one H plus ion to become produce water. So addition, subtraction of H plus ion from a compound gives you an acid. Addition of a H plus ion, it gives you acid, and subtraction of H plus ion is called a base. So if any compound, for example, I will say, uh, I will say HCl, then addition of H plus ion will give you what? H2Cl plus. For example, I will say CH3COOH. If you add one more H, it gives you CH3COOH2 plus. That means it is an acid. Subtraction of H plus ion means CH3COO minus. It is a conjugate base. So conjugate acid and conjugate base means from a compound, if you are removing H plus ion, it gives you conjugate acid. Similarly, from a compound, if you add H plus ion, it's called as a conjugate base. So depending the remember always the addition results in the addition of H plus ion gives rise to an acid. Subtraction of H plus ion gives rise to a base. This is called the constant Lowry concept. Then one is called Lewis concept. In Lewis concept, what happens in this case that any substance which donates a pair of electrons is called a Lewis base. For example, ammonia is a Lewis base because in ammonia, the nitrogen atom has a lone pair of electrons. It can donate to H plus ion to give you ammonium ion. So ammonia is a base. It is a Lewis base. Similarly, H plus ion can accept a pair of electrons from ammonia. So H plus is the Lewis acid. So I can say ammonia and H is a Lewis acid base theory. Similarly, BF3, boron trifluoride, BF3 is a Lewis acid because boron is an atom which is electron deficient. So it can accept a pair of electrons from ammonia. A reaction between BF3 and ammonia is also an example of a Lewis acid base theory. Then you can see polyprotic acids means any compound. For example, I can say H2CO3 or I can say carbonic acid H2CO3. It gives you H plus ion to give you HCO3 minus. HCO3 minus can again lose one proton to give you CO3 2 minus. So I can say H2CO3 is a diprotic acid because it can lose two protons, two H plus ions on dissociation, but one each at one time. That means H2CO3 will give you first one H plus ion to give you HCO3 minus. HCO3 minus again gives one H plus ion to give you HCO3 2 minus. It's called polyprotic acid. Similarly, H3PO4 can give you 3 H plus ion simultaneously, continuously. For example, H3PO4 first give you one H plus ion, then the compound, then the conjugate acid obtained will give you again one H plus ion. Then third one to give you one H plus ion, to give you PO4 3 minus. Means 3H plus and PO4 3 minus. As phosphoric acid in total results in the formation of 3H plus ion. It is called a polybasic acid. Polyprotic acid. Then you see many expressions are there. Then we go to next one is the buffer capacity. I think you know buffer. Buffer means a particular stage of a solution in which if you are adding few drops of acid or few drops of alkali, there will be no change in pH. So buffer is very important in food stock industry or in also in packaging industry, food packaging industry, because you know the change in pH can destroy the food. Therefore, you have to see that the food has not been destroyed, hence its pH it should be maintained. So pH, maintaining pH is nothing but a buffer. So you have to add a buffer or to add a buffer solution which will not change the pH appreciably and under ordinary condition. So buffer capacity is the actual the you can say that how much of H plus or how much of OH minus, and if you add, then it will not change its value of pH. Then we can say the buffer capacity. Formula is there. You can see the formula also, and also you can draw a graph. That is buffer capacity versus the log of ratio CNA by CHA. CNA means students acetic acid, salt, sodium salt or acetic acid. CHA matlab it is called as acetic acid. So a graph, you know, I have told you salt ionizes to give you CH3CO minus and H plus. Therefore, in any chemical reaction, if the reaction is between the conjugate acid and conjugate base, then you can take logarithm of these things. Along with also you can take the buffer capacity and you can draw the graph. It looks like a heap, just like a mountain peak. From that you can know that buffer capacity of the compound and its relation with the its concentration. This topic is mainly mathematical topics are there. Many mathematical reactions are there. Mathematical expressions are there also. You can see it. You can also see how the pH has been calculated. How to calculate pH? pH is nothing but negative logarithm of H plus concentration, and pOH is negative logarithm of pOH minus concentration. pH and pOH, if you add, it gives you 14. That means if you know the pH value, you can calculate the pOH value and simultaneously. There are some questions mentioned. You can read these questions. They are in the table also. There is not much in this chapter. इतना सा था. Then next we'll go to next unit 8 will go neutralization titration 1. Oh, means to know neutralization means what? Means strong acid, strong base, strong acid, weak acid, strong base, and weak acid, weak base. So in this way you can see that there are deep titrations basically of 4 types. Titration of a strong base against a strong acid, then weak base against a strong acid, then weak acid against a strong base, and then weak acid and weak base. These things we'll also discuss in this system, and also we'll learn about the indicators. All these things are there, and we'll discuss one by one. Can I take 1 or 2 minutes break? Hello?
Yes, sir.
Can I take 1 or 2 minutes break?
Okay, sir.
Okay. Shall I continue? Hello. Shall I continue, Jitendra?
Yes, sir. Continue.
Okay. So there are different types of titration methods for there. As I've explained you, acid-based titrations are four types: strong acid, strong acid, weak acid, strong acid, strong acid, strong base. Now we'll go one by one, discuss about these things. The basic concepts of titrimetry, primary and secondary standards. So you can see here that there are some methods. Before titration, you have to have some precautions like it must be easy to obtain, to purify and dry, and to preserve in pure state. Then substance should remain unaltered during the weighing processes. The substance should be capable of being tested for impurities by qualitative analysis. It should have a high equivalent so that the weighing errors may be negligible. The substance should be readily soluble under the experimental conditions. All these things are the precautions, all these things are you can say preconditions which you have to be followed before doing some titrating. Then titration curves are there. So I am discussing one by one. First of all, strong acid and strong base. HCl and NaOH are the common examples. And we are getting water plus Na plus and what? Cl minus. Then you can see the graph. This is the graph you can see in the screen. Interrelation curves of 100 cm to HCl with NaOH of same concentration. So the graph looks like this. And if we are getting the concentration of NaOH, then you can get also one more graph. For example, a different pH. pH is 1, pH is 0.1, 0.01. Then you can able to, and by getting the NaOH concentration and pH, you can able to draw another graph. You can see this graph. Here you see the concentration varies from 1 to zero point 0.1 to 0.01. Is alkali. And you can see the same thing there, pH versus alkali added. You can see a graph like this also. And for different types of indicators, the graphs also looking different. And the indicators are, you can say, thermal phenolphthalein, phenolphthalein, then bromothymol blue, methyl red, and more commonly methyl orange. These are the indicators which are used for this particular titration, strong acid and strong base. And you can see the graph where the pH value lies in between. From that you can able to know whether your compound is acidic or basic or in which stage of its. Then you can see weak acid versus strong base. So in this case, the weak acid is acetic acid, and the strong base is NaOH. And then you see there will be reaction between H plus and OH minus of acid and alkali to give you water and Na plus and CH3COO minus. Then by varying the concentration of acetic acid and NaOH, you can open the graph. The graph is on the screen. You can see the nature of the graph. And you just compare that. The nature of the graph as obtained in case of strong acid, strong base is completely different from the weak acid and strong base. You can see here the equivalent bond is much more higher as compared to strong acid, strong base. And remember always, for any of the titrations, you can, as you are doing acid and base titration, so you can able to calculate the pH of the acid and base also. When you see a different concentration of NaOH and acetic acid, you can able to calculate the pH. The table indicate that how strong acid and strong bases combine to form a complete reaction mixture in which the concentration of strong base prevails. Means if you are adding the weak acid to a strong base, then the strong base and weak acid will utilize, for the excess of the strong base remains and the solution becomes alkaline in nature. Mean pH is more than 7. If pH is more than 7, solution is alkaline in nature. Then we have titration. Uh, Weak base versus strong acid. Weak base versus strong acid. The strong acid is hydrochloric acid. The weak base is ammonium hydroxide. So when ammonium hydroxide combines with hydrochloric acid, it gives you ammonium ion and chloride. And also you can calculate the H plus concentration of the expression, and you can see the graph. The graph looks like this. pH. So, hello, hello.
Yes, sir.
Just I'll take 5 minutes here because reaching the spot. So once I'll go record from the first, then I will again start.
Okay, sir.
I will be Hello. Hello. Jitendra.
Yes, sir. Yes, sir.
Actually, just I've reached the spot. Actually, I have a medical issue. I've reached the medical. So, can I stop the class today here? No problem.
Okay, sir.
Okay, but I think I will be in the mute position for a few minutes. Then I will stop it. Okay.
Okay, sir.
Okay.